Okay, hi guys, so get started with this lecture. So first of all, a note at the starting that any fractional conversion of reactant does not depend on the initial concentration of reactant in first order reaction. Okay, so let's say we have to calculate when will the concentration of the reactant, or rather the reactant, 1/4 of the reactant converts itself into products, or we have to calculate T1 by 4. Okay, so if the 1/4 of the reactant has already been converted into product, then what fraction of the initial, or rather the concentration of A is present at this point of time? It would be 3 by 4 of the initial concentration. That means 3 by 4 of A, and we know that A at any point of time t for a first order reaction would be A naught minus X, and X in this case would be 1 by 4 of A. So A at this point of time would be A naught, which is A, and X would be 1 by 4 of A. So this would be 3 by 4A. Now we know that alpha is equals to X upon A. X is 1 by 4 and A is A. So we just cancel out A from both the numerator and denominator side. So we get alpha equals to 1 by 4. So just putting the value of alpha in this equation, so we will be getting T equals to 1 by K ln 1 upon 1 minus alpha means 1 minus 1 by 4. So this, on simplifying, this is by the way T1 by 4, the time at which 1/4 of the reactant has converted into product. So T1 by 4 would be equals to 1 upon K ln 4 by 3. So this time limit, or the time at which 1/4 of the reactant converts into products, is independent of the initial concentration of the reactant for a first order reaction. So this is what we meant by the note. Next, let's see half-life. So half-life is nothing but time at which half of the reactant is converted into product. By half of the reactant, I mean the initial concentration of the reactant goes to half. So clearly X would be A by 2. So we can be writing that alpha would be equals to also half, and we know that T equals to 1 upon K ln 1 upon 1 minus alpha. So T would be equals to 1 upon K. This is T half, rather would be 1 upon 1 minus 2, 1 minus 1 upon 2. So this would be equals to T half. This implies T half would be 1 upon K ln 2. Okay, so the graph of the same would look like this. If we compare the T half with the initial concentration A, it would be a constant line. It does not depend on the value of A. So this is independent of the initial concentration of reactant. Independent of the initial concentration of reactant. Okay, now let's say we have to calculate T3 by 4. So T3 by 4 is nothing but the time at which 3/4 of the reactant is converted into product. So we can say that X is 3 by 4 of A, or alpha is 3 by 4. So from this we can write, we already know that T equals to 1 upon K ln 1 upon 1 minus alpha. Just substitute the value of alpha here, and we'll be getting T equals to T3 by 4 rather. T3 by 4 would be 1 upon K ln 4. Okay, so this can be written as T3 by 4 equals to twice 1 upon K ln 2, and we know that 1 upon K ln 2 is T half. So T3 by 4 is twice of T half for a first order reaction. Okay, now let's see one more example in which we have to calculate T7 by 8. T7 by 8 simply means when 7 by 8 of the reactant is converted into product. So okay, I can directly write alpha is 7 by 8. So from the equation of T, which is 1 upon K ln 1 minus 1 upon 1 minus alpha, we can write T7 by 8 would be equals to 1 upon K ln 1 upon 1 minus 7 by 8, which would be nothing but T7 by 8 would be ln 1 upon k ln 8. Okay, so this can further be reduced and be compared with t half. Like we can write 3 1 upon k ln 2. We can write, this is some mathematical conversion. This is 2 to the power 3, so 3 can come aside and ln 2 would be remaining. So 2 to the power 3, the 3 can come outside the ln term, so we can write T7 by 8 for a first order reaction would be 3 times T half. Okay, similarly T15 by 16 would be 4 times T half. So the same analogy can be applied and can be extrapolated. So just note here that amount of concentration of reactant after 2 half-lives would be after 2 half-lives we are saying, so initial concentration divided by 2 to the power 2. Similarly we can write that this is the leftover because we are writing after. Similarly we can write that amount of reactant or rather concentration of reactant, to avoid any sort of confusion, amount of concentration of reactant left after n half-lives would be initial concentration divided by 2 to the power n divided by 2 to the power n. Okay, and as a matter of fact we know that all radioactive substances decay or disintegrate always follow first order kinetics. All radioactive substances decay or disintegrate following first order kinetics. So with this we come to the end of this lecture. In the next lecture we'll be seeing second order kinetics. So till then, good luck and goodbye.